Let us take the greatest common divisor. How to find the greatest common divisor? Should remember, GCD is also known as highest common factor. So GCD and HCF are one and same. Let us find what is a greatest common divisor. Okay, two numbers may have several common divisors, right? That's what we found. Any two numbers will have several common divisors. The largest among them is called the greatest common divisor. That is otherwise called GCD. What is the largest among the common divisors is called the GCD. Let us see that through one example. There is a question, find the GCD of 12 and 16. To find the GCD, we have to use the step 1. There are several steps, right? Write the divisors of 12 and 16. Write the common divisors of 12 and 16. Select the greatest common divisor, right? These are the steps. First step. Let us write the divisors of 12. 1, 2, 3, 4, 6 and 12. Divisors of 16 is 1, 2, 4, 8, 16, right? The common divisors is 1, 2 and 4, right? Here it is 4 and there is a 4. That's all, nothing else. So 1, 2 and 4 are common divisors. The greatest common divisor is among 1, 2, 4. What is the greatest one? 4. That is the answer. There is another method to achieve that. For that we have to find the prime factors of 12 and 16 and circle the common divisors. Okay, this is a longest process in which you have to write all the thing and find out, right? Yes, we can find the common prime factors of this number and circle the common divisors. Third, after finding the common divisor, we have to multiply the encircled common divisors. So in this case, step 1, what are the prime factors for 12? 2 into 2 into 3, right? We remember 12, we have to, how to find that thing, right? We have to first find this thing, we have to do a circle of this, we have to 2 branches, right? Then it will be 6 here and 2 here. Remember, we did all these things, right? Then we have to, these are the 2 branches. Then 6 can be branched off into 2 more. How can they be written? Okay, 2 and here it is going to be, yes, 3. Likewise, we went on doing this. Hence, these are all the factors. 2 into 3 into 2. So if we align 2 into 2 into 3, this is how we got 2 into 2 into 3. Likewise, find the prime factors of 16. That will be 2 into 2 into 2 into 2. Like you remember how to do 16. So the prime factors of 16 we can find as 2, 2 and 2 and 2 here, right? So all those things comes here. So 16 can be written as 2 into 2 into 2 into 2. So if you take the common, here the common divisors, we find the common divisors as 2 into 2 and 2 into 2, right? So 2 into 2. So these are all the common divisors and you multiply them to get 4. This is the way we use with prime factorization, right? Let us see one other method, how it is done. Okay, here we do the third method. We divide 12 and 16 by 2, right? Look at this method. We just divide it with 2. What is the common thing we see? Divide by the common divisor. We know these are even numbers. So 2 goes there. 2 6 times 2, 8 times. Then we once again divide it by one more 2 because these are even again. So this becomes 3 and 4. So now we see these 2 into 2. There is nothing common after this, right? You don't have a common between 3 and 4. So they are reminders. We leave them. And we take only these 2 2's and multiply them to get the common divisors, greatest common divisor as 4. Okay. this is method 3. This is one other shortcut method. Finally, in this fourth method, it's called continued division method. It's useful for finding the GCD for large numbers like 648 and 124 like that. Here we divide the big number. If there is two numbers, we divide the big number with the small one, right? Which one is big? For example, we take 124 and 648. We divide the big number by the small one, okay? Then the divisors are divided. Look, then the divisors are divided in succession by the reminders we got, right? So for example, what is the remainder we got in this? 5 times is 620. How much is left out? 28 is left out. So 28 is once again the 124 is divided by the 28 guy. 28 is small, right? Now 124 is big. So we are dividing the remainder, the other bigger, the divisor. Which is the divisor? 124 is the divisor. That way we get 112 here, right? Now we get, we divide, what is the remainder? 12 is the remainder when we subtract this one. But 28 is the divisor. Once again we divide the divisor with the remainder we got. Likewise it keeps on going until finally, in this case what we have in 28 minus 24 is 4. Now we bring this divisor inside. Now divide that with the remainder. So 3 times. Now 0, right? Until we get remainder as 0, we keep on dividing it, okay? That is the idea behind this continued division method. That is, divide the bigger number by the smaller number, then the divisor are divided in succession by the reminders got. This division should be carried out till we get the remainder 0. The last divisor of is the GCD of the given number. What is the GCD? The last divisor is the GCD. Which one is the last divisor here? Oh, the last divisor is 4. After 12 was the one before 1, right? So the last divisor is the 4. So therefore we find the last divisor is 4. The GCD of 124 and 648 is 4. This is one other tricky, easy way of, getting the divisor, greatest common divisor for a big number like this one, okay? If you take another example here, right? 43. Find the GCD of 10, 15, 20 by shortcut method. What is the shortcut method? Yes, we just write all this number here, right? And then we use the what? Yeah, the division method, okay? We have all the 3 numbers here, 10, 15 and 30. What divides 10, 15 and 20? What is in common? We know by default 5, right? 5 goes 2 times, 5 goes 3 times, 5 goes 4 times. Can we divide any other common number? No. So boom, boom, boom. We don't use those things. Only left out common factor is 5. Okay, therefore GCD is 5. This is the shortcut method. Example 44. Find the GCD of 3 numbers. Which one? 12, 18 and 60 by prime factorization method. Here is the solution. First we find the prime factors for 12, 18 and 60. How do we do the prime factors? Remember 12, we have to write the branching method. 6, 2, right? You remember this? We have to do this. This makes it easy. Then 6 can be branched off into 2 and 3. Okay. Then this can be this thing. So 2, 3 and 2. So 2, 2, 3. Likewise 18 gets 2, 3 and 3. 60 gets 2, 2, 3 and 5. But what are the prime factorization method? We have to find all the common factors. We found this is 1 and 3 is one common method, right? So the common factors are 2 and 3 for all these 3. So therefore GCD is going to be multiplication of the 2 common prime factors. You should remember 2 common prime factors. In case of normal factors, we don't multiply, we take the highest factor. But if we take prime factors, we multiply them. Okay.